10-gauge 3½ inch smooth bore test barrel. By the mid-20th century, the 10-gauge was sliding toward irrelevance, an old market hunting heavyweight with more nostalgia than shelf space. It came back for a very modern reason: the late 1980s to early 1990s transition away from lead shot for waterfowl pushed hunters into steel, and steel's lower density meant equal payload suddenly demanded more volume. Standard 12-gauge loads struggled to carry enough larger steel pellets to keep patterns useful at distance, so the 3½ inch 10-gauge became the specialist option: heavy payload capacity, fewer compromises, and a clear role in the goose blind until the 12-gauge Super Magnum started eating its lunch. Under SAMI standards, a 3½ inch 10-gauge sits at the top of the shot shell measurement ladder because it turns every claim into an industrial stress audit. The SAMI test barrel setup anchors pressure and velocity statements to hardware that can absorb repeated, instrumented firing without drifting. In this lane, power is an envelope, velocity recorded at a defined reference distance, chamber pressure captured by approved instrumentation, then judged against statistical limits that factories can actually hold across a production lot. Big payloads invite variance, and this class forces the conversation back to controllability. A 10-gauge Magnum doesn't punish feelings. It punishes sloppy process. 12-gauge 3½ inch smooth bore test barrel. The 12-gauge Super Magnum arrived as a straight answer to a supply chain complaint. Hunters wanted 10-gauge payload capacity without a 10-gauge guns weight and specialized ammo ecosystem. Mossberg's 835 Ultimag in 1988 put a commercial platform behind that idea. Then ammunition makers followed with loads that tried to pack big bore behavior into a narrower bore. That creates an internal ballistics problem: large payload, heavy powder charge, tighter bore constraints. So pressure management and recoil became design constraints, not afterthoughts. That is why the 3½ inch 12-gauge earns its own smooth bore test barrel. Chamber volume invites ambitious load designs and aggressive velocity targets, and SAMI standards treat that ambition as a quality control problem. Keep pressure within defined ceilings, keep velocity within the recommended band under standardized conditions, then prove the numbers hold across samples rather than a lucky handful of rounds. This level reads like a checklist because it is all constraints. Payload increases drive recoil, and cycling demands upward, while the SAMI standard stays narrow. Verify what the chamber actually sees under the prescribed test conditions. Longer shells translate into more ways for powder behavior, wad design, and component variability to widen the spread, and the test barrel is the referee that doesn't negotiate. 12-gauge 3-inch smooth bore test barrel. Post-World War II manufacturing made the 3-inch 12-gauge feel ordinary in the best way: better alloys, better consistency, and eventually plastic hulls turned Magnum from a special order curiosity into a mainstream catalog item. For decades, this chamber length defined the duck blind: more payload than the 2¾ inch standard, less brutality than later 3½ inch loads, and broad compatibility across pump, semi-auto, and double guns. It wasn't a revolution, it was production scale turning capability into routine. In current practice, the 3-inch 12-gauge is where Magnum becomes a production reality rather than a niche. The smooth bore test barrel for this chamber length exists to make data comparable across manufacturers and across time, which is the only way power has meaning in a regulated supply chain. SAMI test protocols rely on repeatable setups, controlled ammunition conditioning, defined shot counts per test string, and equipment checks that prevent chronographs from reporting fantasy numbers. Velocity becomes a disciplined metric instead of a marketing line because test barrels and commercial guns will differ in dimensions and barrel length, and SAMI standardization is the only reliable bridge. This chamber length is the workhorse case study, widely used, heavily commoditized, and full of misconceptions that disappear once the envelope is written down. 12-gauge 2¾ inch smooth bore test barrel. World War I and a century of police work gave the 2 3/4-inch 12-gauge something most cartridges never get: institutional inertia. This was the trench gun era trench broom load length, controversial enough to trigger a German diplomatic protest, and later it became the default language of law enforcement shotguns, clay sports, and household gun cabinets. Ubiquity creates a unique burden. This shell length has to behave safely across an absurd variety of actions, tolerances, and decades of metallurgy. Most of the shotgun world still orbits the 2 3/4-inch 12-gauge, and SAMI standards treat it like the ecosystem's centerline. The smoothbore test barrel is less about chasing extremes and more about building a stable measurement baseline for a huge diversity of loads. Pressure is captured through approved transducer methods, then evaluated using limits that assume real-world manufacturing variation rather than laboratory perfection. Velocity is recorded at a defined reference point under controlled conditions, so companies can speak the same numerical language even when production guns differ. This barrel class also captures the industrial meaning of power. The chamber event matters more than the legend. The most common shell length gets the least tolerance for sloppy claims because it has to remain safe in the largest legacy fleet. 12-gauge 3-inch rifled test barrel. Slug zones turned rifled shotgun barrels from a niche into a necessity. In many Midwestern and Northeastern areas, deer hunting with rifles faced restrictions due to range and safety concerns, so hunters leaned on shotguns, but smoothbore slugs were a limited tool beyond short ranges. The industry's response was a hybrid: sabot technology, a sub-caliber projectile carried by a plastic sleeve, paired with rifling to impart spin and stabilize flight. The result stayed legally in the shotgun lane while behaving much closer to a large-bore rifle system, and that shift mattered inside the barrel as well as downrange. Rifling changes the measurement problem before anyone argues about payload. A rifled 12-gauge test barrel exists because projectiles intended to engage rifling can reshape pressure curves and velocity behavior in ways a smoothbore will not represent. Under SAMI test protocols, the barrel is the category boundary. Without it, numbers from one lane get misapplied to another. Pressure is still pressure, and velocity is still velocity, yet system response differs enough that separate fixtures are the only way to keep data honest. The practical point is discipline. If rifling is part of the design intent, SAMI measurement methods have to reflect it. The lab does not reward gun counter lore, it rewards repeatability. 12-gauge 2 3/4-inch rifled test barrel. The 2 3/4-inch rifled lane grew because a lot of users valued control over brute payload. Many hunters found 3-inch Magnum slug recoil counterproductive for real accuracy, while 2 3/4-inch sabot loads delivered practical performance with better handling. Agencies and tactical teams also had reasons to care. Single projectile options for specific roles, with constraints that differ from rifle calibers. Mixing hardware and load intent is where things get messy. Rifled intended projectiles in the wrong bore conditions produce unstable behavior, so the category needs a dedicated testing lane. Shorter chamber, rifled bore, and the same requirement for comparable data across manufacturers. This is a lane for loads meant to behave like single projectile systems under rifled conditions. The boundary is the point. It prevents a 2 3/4-inch rifled discussion from borrowing smoothbore assumptions, which would blur pressure limits and confuse velocity expectations. SAMI test protocols remain consistent. Define the setup, control the conditions, collect a statistically meaningful sample, then judge the lot rather than the lucky round. That process matters in procurement terms. Buyers want a distribution they can live with. It also explains why test barrel data can diverge from field chronograph results without implying deception. Different hardware, different dimensions, different outcomes. 12-gauge 2 3/4-inch smooth bore test barrel. A huge legacy fleet is a safety problem, not a trivia fact. Millions of 12-gauge shotguns remain in circulation, including older designs and older steels that were never built with modern performance margins in mind. That reality forces a quiet compromise. A shelf-bought box of shells must be safe across a wide spectrum of firearms, not just modern-proofed platforms. SAMI pressure limits in this category function like a firewall, balancing commercial performance with compatibility risk. This second pass on the 2 3/4-inch smoothbore lane works as the read the sheet moment. SAMI tables speak in controlled measurements. Velocity stated from a defined muzzle reference distance and pressure expressed with statistical guardrails. Map-style ceilings describe what a firearm must endure repeatedly across production ammunition, which is why industry treats them seriously. The analyst line is simple: risk management wearing a ballistics uniform. Exceed the pressure envelope and service life collapses. Drift velocity far above the band and practical behavior changes in ways that matter for safety and predictability. In this lane, power is bounded capability, not attitude. 16-gauge 2 3/4-inch smooth bore test barrel. 16-gauge once had a clean pitch, near 12-gauge payload in a lighter gun that carried like a 20. It also had a clean nickname, Sweet 16, and it earned it in upland fields. Then standardization did what standardization always does. It consolidated around the most profitable lanes. Organized shooting formalized around 12, 20, 28, and 410, and manufacturers poured production scale into 12 and 20 platforms with broader demand and more chamber length growth. 16-gauge got stranded in an ecosystem that slowly thinned. That thinning is why a dedicated SAMI test barrel lane still matters. The gauge has its own pressure and velocity behavior, and the standard preserves a measurable identity that isn't dependent on internet stereotypes. Manufacturers can publish numbers with credibility using the same disciplined setup as the mainstream gauges, which is critical when the installed base includes plenty of older doubles. Consistency matters more when sourcing is constrained and product variety is narrower. The practical punchline: when a gauge becomes a cult classic, standards become its life support. 20-gauge 3-inch smooth bore test barrel. The 3-inch 20-gauge is magnum logic applied to a lighter platform. As hunters pushed lighter guns into roles once dominated by 12-gauge loads, waterfowl, turkey, heavier fieldwork, the industry looked for payload capacity inside a smaller bore system. That produces a real internal ballistics constraint. More powder and payload packed into a narrower tube demands disciplined pressure management. This chamber length exists because industry wanted capability without forcing everyone into heavier guns. SAMI standards for this smoothbore test barrel frame power as a managed expansion. More internal volume opens design space, yet pressure ceilings remain the hard boundary. The standard matters here because performance chasing amplifies lot-to-lot variation, and variation is what creates surprises in the field and in liability paperwork. This lane should read like an engineering brief. The barrel class exists so manufacturers can validate that their 3-inch 20-gauge offerings live inside a predictable envelope rather than a lottery. The punchline lands quietly. Longer shells buy options. They don't buy free physics. 20-gauge 2 3/4-inch smooth bore test barrel. 2 3/4-inch 20-gauge survives because it is useful and manageable. It is common in training pipelines, common in upland hunting, and common in lightweight guns where recoil tolerance shapes who can shoot well for long strings. That light gun reality makes ammunition consistency more important than people admit. A pressure spike that a heavy 12-gauge platform shrugs off can feel sharp and disruptive in a trimmed-down 20-gauge receiver. SAMI test protocols keep this lane numeric and comparable, pressure captured with approved methods, velocity captured with controlled instrumentation, both tied to sampling rules that punish cherry-picking. The key manufacturing point belongs here. Recommended pressure and velocity values are set for production control, and a commercial shotgun with its own dimensional tolerances will not always reproduce the same readings. SAMI standards provide a stable reference point so claims don't drift into folklore. The constraint-driven line is simple. The chamber doesn't care how light the gun is. It cares how the gas event behaves. 20-gauge 3-inch rifled test barrel. Modern slug technology turned 20-gauge rifled guns into serious deer tools not consolation prizes. As sabot designs improved, shooters discovered that a well-built 20-gauge slug setup could deliver practical accuracy with less recoil than many 12-gauge slug systems, which shifted buying behavior. Precision started selling better than brute force, and the market responded with more rifled barrels and more high-performance 3-inch loads tuned for them. Rifling plus a 3-inch 20-gauge chamber creates a specialized measurement category aimed at rifled engagement. SAMI test protocols use rifled test barrels here because smoothbore data would misrepresent pressure curve shape and velocity response for rifled intended systems. The doctrine is measurement discipline, correct tool, correct procedure, correct category, then accept the numbers. Anything else turns selection into superstition. The punchline fits the theme. The most dangerous mistake is treating a correct number from the wrong lane as universal truth. 20-gauge 2 3/4 inch rifled test barrel. This lane is refinement, not escalation. A 2 3/4 inch rifled 20-gauge category exists for users who value control, cycling consistency, and manageable recoil over maximum velocity. It also matters for platforms and shooters where follow-up speed and handling are part of the real capability. The technical challenge is straightforward. Projectile engagement with rifling has to be consistent without leaning on the extra volume of a Magnum case, so load tuning becomes more sensitive to powder characteristics and component tolerances. A rifled 2 3/4 inch 20-gauge test barrel reinforces category discipline. Rifled intended behavior must be measured under rifled conditions, and SAMI standards depend on keeping those lanes separate. The measurement logic stays stable. Condition ammunition, run defined sample sizes, capture pressure and velocity with approved equipment, then judge results against limits built for production realities. That is power in an industrial sense, repeatable, bounded, and auditable. If you enjoyed this video, consider giving it a like and sharing it with other firearm enthusiasts. Don't forget to subscribe for more deep dives into some of the most interesting guns ever made. And if there's another gun manufacturer or topic you'd like us to cover next, let us know in the comments below. Thanks for